I'm here in the Republic Finance Gallery because we have a new exhibit here called The Art and Healing Power of Jazz. And it's not just an art exhibit here, but we also have some stuff going on in the auditorium, some featurettes which talks about the healing power of jazz and how jazz music affects the brain. So lots going on here in this space, but we're not here to talk about jazz right now. We're here to talk about the largest star ever recorded so far in our universe. So let's go back to the office and take a look at that. Apologies for last week. I had COVID last week. That was a whole lot of fun. So I'm back here. Still got a bit of a cough, but we can work with that. So in the planetarium industry, I've noticed a few things. One of the things I've noticed is that some people who work in the planetarium industry and make shows are interested in certain things. Some people really like planets. Some people really like exoplanets. Some really like comets. I like stars. I like to find the biggest stars. I'm really interested to know which stars are the biggest stars. I wanted to be a alien today. Here we go. Alien in a coffee shop. So what is the largest star that we know of? Well, there are a few things we have to consider here. And we're going to take a look at some of the largest stars we know of. It's hard to measure these stars to know which one exactly is the largest, but I'm going to give it a good shot here. Well, we used to think that WOH Scuti was the largest star ever recorded, but new evidence may suggest that WOH Scuti is a lot smaller than they initially thought. Plus, there's a new largest star candidate out there called WOH G64. Now, when it comes to talking about stars and how big they are, there are two things to consider. There is the mass and there is volume. Mass is how much stuff, how much material is inside the star. What exactly composes the star, the mass of it. The volume is how much space it takes up. So some stars can be very massive but rather small. Some stars can be very voluminous but not containing a whole lot of mass. So, for example, it is believed that once our own star, the Sun, has consumed all of its hydrogen, it will then begin to bloat to the size of a red giant star as it begins to consume its helium. Now, it'll get a lot bigger, but it will also contain less stuff to consume. So when it comes to the largest star in the universe that we know of, any search will tell you online that it is a star called WOH Scuti. So let's go over here to this. I'm going to find WOH Scuti, and it's inside. It is inside this constellation called Scutum. Whoosh. There we go. So let's dial this down a bit here to see what WOH Scuti looks like. So yeah, it is a huge star, very bumpy and gross looking there, but let's back off a little bit there. So there is WOH Scuti. Now the original measurement, let's get up a bit closer again. Now, the original measurement of WOH Scuti is believed to be around 1,700 times the size of the Sun. But they've measured it, and they believe that it's only about 775 times the size of the Sun. They remeasured it, Now, with that new measurement, WOH Scuti doesn't really make the top 10. So it still could be the size that they think it is, around 1,700 times the size of the Sun, but it is very unlikely that it is going to be as big as that. So what is the largest star that we know of? Again, there is some speculation when it comes to this next star. Let's go back to planet Earth over here to show you where this next one is at. Those are the constellation lines. There we go. Okay, there is the Sun. Earth. So the next star we're going to take a look at is a star called Stevenson. I'm trying not to type here with my mic in my way here. There we go. You can find this again in Scuti. So let's go visit that star up close, and you will see it looks a lot like UI Scuti. But we're going to back off a little bit here. See this nice little halo here we've got going on. This little sort of torus cloud of material that we've got going on there. Well, how big is this particular fellow? Well, if you replaced our sun with this star, it would take up enough space to engulf the orbit of Saturn. It would take light about 9 hours to loop around this star, while a beam of light would only take 14 seconds to loop around our sun. Now, there is a theoretical limit to how large stars can get. That is 1,500 times the radius of our sun. That is the stellar evolutionary limit that they believe a star could get. Now, the reason why I bring this up is because we're not quite sure how far away Stevenson 2-18 is from us. Now, there could be an error of about 50%. And because of this error, there could be a large discrepancy in size. Now, because of the current estimate, if the current estimate is correct, Stevenson 2-18 is about 2,000 times the radius of the sun. So it kind of blows up the theoretical limit of what's possible of the stellar evolution that we believe to be the limit for stars. Now, with this is a level of uncertainty, and we can't really say if Stevenson 2-18 is the largest star or not. I'm going to go back to planet Earth here. Back home. So, based on our best measurements and certainty that we have for the largest star, what are we most confident at is the largest star that we know of? Well, that will be the star I mentioned at the very top of this, which is going to be WOH G64. There we go. And that is going to be in the constellation Dorado. And you'll see, let me take these little constellations down. You can see that this is going to be in the Large Magellanic Cloud. There we go. Let's dot that down, and of course it looks very similar. Now, this isn't exactly how it looks. This is just an artistic representation of what this star might look like if we dialed the exposure down so that we could see it. Again, we have this nice little torus cloud of material here. Well, that's important. I'll get into that in a second. So that is WOH G64. You can find that in the Dorado constellation. In the Large Magellanic Cloud, that is around 165,000 light years away. It's quite far away. Now, this star is believed to have a radius of 1,540 times that of our sun. And that means if it replaced our sun, it would take up enough space to extend out to the orbit of Jupiter. That's cray-cray bananas. Well, I mentioned this little torus cloud here, this little cloud of material right there, because we're taking a look at this out in space. You'll see this little cloud of material there, and this is what it has expelled over time. Now, for this particular star, now you could take all of this material that surrounds this star, and you could create and make up our entire solar system 9 times over. That is how much stuff that is in the little cloud of material there. Now, is this the largest star? Probably not. I'm sure there will be other stars that will usurp this particular star here. Now, when talking about star sizes, it's very difficult to accurately measure stars. They're very far away, and we are constantly refining how we measure these stars. Now, as time goes on, more techniques and better techniques will arise, and we will be able to get a better understanding of what the largest star is. So I am sure at some point another star will come along, or we will discover another star that will usurp the WOH G64 star out there. Only time will tell. Well, speaking of time, we have a new planetarium show that we will be debuting soon. Let's go back over here to my... There we go. Oh, alien body here. There we go. Yeah, there we go. All right. sip here of my coffee. New show starting very soon. It is called Supermassive Black Holes Unveiling the Invisible. Check our website for show times because the shows are always at different times. We have school groups, there's cancellations sometimes. So check the website and our planetarium show schedule to see when this new show is. Let's run the trailer to see what it looks like.
When we gaze at the stars on a calm summer night, we perceive a beautiful, peaceful, and ordered universe. We do not realize that it is alive, fierce, and sometimes extremely violent.
That is Supermassive Black Holes Unveiling the Invisible, starting soon at the Louisiana Art and Science Museum. Hope you enjoyed this little exploration into stars and the largest stars that we know of. I will see you next week if I'm not sick again, and we will do another Astronomy and Coffee.